Hello everyone. Today we're going to finish up the last three skills in the 8th grade unit, solving equations with one unknown. First, we're going to talk about the number of solutions to equations. Then we're going to deal with number of solutions to equations challenge. And then lastly, we're going to finish off with sums of consecutive integers. So let's start with the number of solutions to equations. So this next slide looks a little bit overwhelming, but let's go through it. And then I also included this with each problem, so you almost have like a little cheat sheet. So linear equations may have one solution. Each expression will have a different rate of change. So basically when you have x equaling a, so x equals 4 or x equals -7, that means that you're going to have one solution. No solution is when you end with two numbers that aren't equal to each other. So for example, let's say I end up with 3 on the left-hand side and -4 on the right-hand side. Obviously, 3 does not equal -4. Therefore, that would be an example of no solution. Let me just write an example in here. So x equals 7. That would be like a regular problem we've been doing. You would have one solution. And then the last one, we have a equals a. So let's say I get 3 equals 3. Well, that's true, which means that there are infinite solutions. Okay, let's take a look at one of these problems. So notice the problem. You're going to have to go through and solve these in order to determine if there's one solution, no solutions, or infinite solutions. So let's start here. I'm going to combine my like terms. I have -3x and -2x, which leaves me with -5x plus 9. And then that leaves me with -12 minus 5x. So at this point, I would add 5x on both sides. It would cancel there. And now look what happens. It cancels here as well, leaving me with 9 equals -12. Does 9 equal -12? No. So this would be where A equals B. So clearly this one is no solution. Let's try another one. The more of these you do, the easier it gets, the more you get the hang of them. So I've got a +20z and a -12z, different signs, so we subtract. That's going to leave me with 8z minus 5 equals 10z plus 8. So now I'm going to subtract 8z on both sides. It's going to cancel there. That leaves me with -5 equals 2z plus 8. Next, I'm going to subtract 8 on both sides. That leaves me with -13 equals 2z. And I can see here I'm going to end up with a fraction as my answer, which is fine. That means we got z equals -13 over 2, which would be an example of x equals some number. In this case, they have a, but in this particular problem, it equals -13 over 2, or -6.5. So this would be exactly one solution. Let's try another one. Here we're going to distribute first. 3 times y is 3y. 3 times 41 is 123 equals 3y plus 123. Now, notice that what I have here on the left, 3y plus 123, is the exact same thing as I have on the right, which means you have infinite solutions. But watch what happens. I would normally subtract 3y, which would cancel there and would also cancel there as well, leaving me with 123 equals 123. So that would mean we have a equaling a, or the same number equaling the same number, which means infinitely many solutions. And what that means is it doesn't matter what number you would plug in, any number will work in this problem if you plug it in for your variable y. Whereas in this case, this first problem, no solution, it doesn't matter what number I try to plug in for x, it will never work in this equation. Okay, let's try another one of these. So I'm going to distribute my 14. That's going to leave me with 14z And let's see, 14 times 3 is 42 equals 14z plus 21. I'm going to subtract 14z, which as you can see, it's going to end up subtracting here, leaving me with two different numbers on either side. Clearly 42 does not equal 21, so this would be a case of no solution, or answer choice A. Melina solved an equation and found it had infinitely many solutions. Which of the following equations did she solve? So we have a multiple choice problem, which means we have to go through each problem. I have a two-step equation here. So I would subtract 8 on both sides. That would leave me with 6 equals 4c. And when I solve for c, I'm going to end up getting the simplified fraction 3 over 2. So this would be an example of one solution. Here, if I divided through by my coefficient, I would be left with m equals 4, which is also an example of one solution. Here, I'm going to distribute. I'm going to keep my left-hand side the same, and then I'm going to distribute my 5. So that's going to leave me with 5b plus 5. Right away, I can see I'm going to have infinitely many solutions, because if I subtract 5b on both sides, I'm going to be left with 5 equals 5, which is true, which means that we have infinitely many solutions with answer choice C. And what's wrong with this one is that I'm going to be left with 4a plus 8 over here, 4a plus 9 over here. So when I cancel my variables out, I'm going to end up with 8 on the left and 9 on the right, which clearly 8 does not equal 9, which means this would be no solution. Okay, let's move into the equations, the number of solutions challenge. These ones can be a little bit tricky. So again, this cheat sheet, typically an equation has this format, especially if you have variables on both sides. Ax plus b equals cx plus d. So as you can see, I have all this information here where it says exactly one solution when a does not equal c, no solution when a equals c and b does not equal d, and infinitely many solutions when a equals c and b equals d. So that's a lot to kind of wrap your head around. So what I've done is I've copied that little cheat sheet onto each one of these. So let's do some problems so you can kind of see what it means. So obviously in this problem, A is represented by P, and then C is represented by Q. So it says, which values of P and Q result in an equation with no solution? Well, that means we're looking at this one. A cannot equal C. So let's see. A would be P and C would be Q. So no solution is when A equals C. So that means P and Q need to be the same number. So right away I can see that B would work because P and Q are the same. And I think that's it. These ones are different. These ones are different. And these ones are different. And notice it does say B cannot equal D at the end. Well, this would be your B and this would be your D. Obviously, negative 45 and 75 are two different numbers. So the only correct answer here would be B, because we were looking for no solution, which meant that A had to equal C, which meant that P and Q had to be the same number. And B is the only answer choice that gives the same number for both. Let's try another one. For which values of P and Q does the following equation have infinitely many solutions? So now we're looking at this one. So we want A and C to equal each other and B and D to equal each other. So right away I can see that B is negative 37 and D is negative 37. So that part works. So now we're just looking for answer choices where your A and C are equal, or your capital P and your capital Q are the same number, which would be that one. B also would work. C also works. And D also works. And notice it does say choose all that applies. So in this case, each one of these answer choices would actually give you infinitely many solutions. Okay, here we're looking for, again, infinitely many solutions. So we're looking for A and C to be equal and B and D. Now notice they switched up your variables here. So instead of B and D, they gave you a capital Q and a 23. So these need to be the same, which means that this capital Q has to equal 23. So right away, I'm going to eliminate answer choice B and answer choice D, because as you can see, that's a negative 23, and we need it to be a positive 23. It also tells us that A and C need to be equal. Well, if C is 46, that means that P also has to be 46. So I'm going to eliminate answer choice A because that's a negative 46 and it needs to be a positive 46. So the only one that works here is answer choice C. Okay. Here we're looking for exactly one solution. So the only thing that we need is for A and C to not equal each other. In this case, that means Q and P cannot be the same number, which means A will not work. B does work because they're two different numbers. C works because they're two different numbers. And D does not work because those would be the same numbers, and we don't want them to be equal to each other. So in this case, B and C were the only correct choices. Okay, the last skill in the unit is sums of consecutive integers. First, let's talk about what does the word consecutive mean? Well, it means right in a row. So if we were to use a variable, let's say n for your first integer, that means that the second integer would be n plus 1, the third integer would be n plus 2, fourth integer would be n plus 3, so on and so forth. If there was a fifth integer, it would be n plus 4. Now let's just think of this hypothetically. Let's say n was equal to 5. Well, think about your number sequence. 5, 6, 7, 8. So this would be n. Your next integer would be n plus 1, which 5 plus 1 is 6. Their third integer would be n plus 2, which 5 plus 2 is 7. And your fourth integer would be n plus 3, which 5 plus 3 is 8. So now that kind of makes sense with why these are labeled n, n plus 1, n plus 2, so on and so forth. So it says the sum of 5 consecutive integers is 505. What is the third number in this sequence? So we're going to say that n equals 5, which means that the next one would be n plus 1, n plus 2, n plus 3, and n plus 4. So that's 1, 2, 3, 4, 5 integers, but it's saying the sum. So watch what I have to do here. I've got n plus, notice I'm going to put them in parentheses. It just helps me to organize my problem to see how many I've added so far. And that total equals 505. Now also be careful here because they're asking us what the third number in the sequence is. So once we solve this, that means we're solving for n, which is your first number in your sequence. We're looking for the third number in your sequence, which would be n plus 2. So I've got 1, 2, 3, 4, 5n. Let's add our constants. 1 plus 2 is 3. 3 plus 3 is 6. And 6 plus 4 is 10. We're going to subtract 10 on both sides. That leaves me with 5n equals 495. And then when we divide through by 5, that leaves us with n equals 5 goes into 49 9 times. That's going to leave us with n equals 99. So that means n is 99, which would make the next number 100, and would make the third number in the sequence 101. Let's try another one. The sum of 6 consecutive integers is 393. So we're going to start with n plus n plus 1 plus n plus 2 plus n plus 3 plus n plus 4 1, 2, 3, 4, 5. I've got 5 done so far. Plus n plus 5. Those are my 6 integers, equals 393. We're looking for the third number in the sequence, which would be n plus 2. Okay, so I got 1, 2, 3, 4, 5, 6n plus 1 and 2 is 3, 3 and 3 is 6, 10 plus 5 is 15 equals 393. I'm going to subtract 15 on both sides. That leaves me with 6n equals, I have to do a little borrowing here, 378. And then I'm going to divide through by 6. And that's going to leave me with n equals, 6 goes into 37, 6 times. So that's going to be n equals 63. Now remember, that's the first number in your sequence, which means that if this is 63, this would be 64. And the number we're looking for would be 65. Okay, notice this one saying the sum of 5 consecutive odd numbers is 145. Well, let's think of an odd number. Let's say my first number is 3. My next number would be 5. My next number would be 7, so on and so forth. Well, if this is n, that means the next number in your sequence isn't going to be n plus 1, but it's going to be n plus 2. And then the next number is increasing by 2 again, so it's going to be n plus 4, because 3 plus 4 gives you 7. So now instead of increasing in increments of 1, you're actually increasing in increments of 2 because you're referring to an odd number sequence. So the sum of 5 consecutive odd numbers, so now I'm going to do n plus 2 plus n plus 4 plus n plus 6 plus n plus 8 equals 145. So that leaves me with 5n plus, let's add up our constants, 2 and 4 is 6, plus another 6 is 12, plus 8 is 20. I'm going to subtract 20 on both sides. That leaves me with 5n equals 125. And my last step is to divide through by 5, and that leaves us with n equals 25. So that's the first number in your sequence. We're looking for the third number. So if I were 25, 25 plus 4 is going to give me 29, which makes sense because if 25 is your first number, your next one would be 27, 29, 31, 33. Okay, that does it for sums of consecutive integers. The corresponding note-taking packet pages are pages 7 through 12. And again, if you'd like to see some additional examples, you can watch the videos on Khan Academy. Have a great day, everybody.